So everybody's coming back inside. Yeah, please fill the room in the front if you can. It's probably better for everybody. One thing, maybe you've seen this funny mobile developer's guide to the Galaxy, which is somewhere. Most of you know this book since years. Grab one if you want. The other thing is, note to the speakers, there is water now in the front. So, besides that, I think we can restart. Maybe you've seen the food is getting ready. Now let's start with Zayat. Actually, you applied for a talk, if I remember correctly.
Yeah.
And you explained me what you guys were doing at Zalando, and I thought, wow, that's pretty actually interesting. Now I'm very excited to see what you're going to explain and how you guys do this flexible layout kit. So give him a round of applause.
Thank you. Can everyone hear me? Yeah?
Yes.
Okay. So yeah, I'm very excited to talk to you today about what we call Flexible Layout Kit. This is a framework written all in Swift that we use in our app every day. Just to start, I want to know how many people know what Zalando is? Okay, good. How many people have used the iOS app? Did an actual order from the iOS app? Okay, that's good. Yeah. Okay, so the idea about Flexible Layout Kit is that it allows us to do dynamic content delivery without any web views, because we're mobile devs. We hate web views. We hate HTML. That's like in our blood. Okay. Okay, so it's going to be first. I'll talk about the problem, why we want to do this, and then I'll talk about the framework itself, how it works, and then I'll dive into the implementation, how we've implemented all this in Swift. I'll show you a demo, and then we'll switch the code, and I'll show you how we can actually extend the framework to add our own UI to it. Okay, so let's start. The problem again, at Zalando, content is everything. The fashion trends come and go. New stuff enter our warehouse every day, and discounts happen in seconds. And so everything has to be very, very dynamic, and we have to have the power to change everything whenever we want to. Fortunately, with websites, this is perfect because you can change stuff and push it to the server, and then everyone has the same. Everyone sees the new stuff. Everyone is on the same page. But with apps, it doesn't work like that. You have release cycles that is in weeks, or now it's days, but still. And even if you update the app with new layouts or with new content, you still have people on the old versions that you have to support, and they can't see the new stuff because they're on the older version. So even if you update the content from the back end, you can't really change the layout. So the solution at least we had in Zalando was to use web views. So the home page was just a big web view that we can change every day or every hour, or so that we can update the people on what's happening all the time. The problem is web views are very slow compared to native apps. They don't have multi-touch. Animations are way harder to achieve, good animations at least. And that's just the user experience doesn't feel the same. I'm pretty sure I don't have to explain to you why web views suck. Last year we decided we have to fix this. We decided we're going to create a new framework. We call it Flexible Layout Kit, and it had to have two goals basically. One, it had to be 100% native, so all the UI has to be native. We actually have this kit also on Android, so it's built natively on Android, built natively on iOS. And the second is that it had to have dynamic content plus dynamic layout. So not just the content, but the layout has to be also dynamic. So imagine what most content apps does. They have the UI in the app, and then they pull the server for data, and then they show it they fill this UI with data. What we want to achieve here is that we want to ask the server what to display, and then the server would send the data and the layout and tell us you have to display it this way, and then we do that. So now it's like 100% controlled by the backend. So this is kind of a bird's eye view of how we planned it to be. We wanted a CMS in the start so that marketing people can update it, basically. This CMS creates JSON templates that gets sent to the app, and then the layout engine inside Flexible Layout Kit gets this template and transfers it into native user interface, iOS user interface, which we can display on the screen. So it's not usually it's the UI requesting content and then you display it, but now we're actually requesting the UI, all of it. Yeah. So the whole idea here is that layout engine. We have to teach that layout engine to create iOS UI from templates. So we started with teaching it very simple stuff like text, images, videos, and buttons and image sets. Once we taught the engine how to read JSON that describes text and then create a UI label from it, and same thing with images, create a UI image view and set its sizes, set everything from JSON. We use these basic 5 elements to create what we call content elements. So these are what actually kind of people see. These are teasers. So a teaser, as you can see, is basically an image and 2 or 3 text objects. So reusability here was a very important choice. And so a teaser element is basically a container that contains 3 elements, and then now the layout engine knows exactly how to display this. So the teaser is just layouting the UI labels and the UI image views in a certain way. Same thing with the other teaser, or a product element, so that it's an image and text, but when the layout engine now sees a product element in the JSON, it knows that, okay, I'm going to get an image and a couple of text fields, but I know how to display them in relation to each other. Same thing with catalogs. Now it's getting a list of product elements. So reusability here was very important to help us achieve things faster. And then we have what we call layout elements. So the first element, for example, is what we call a list. It's basically a container that can contain content elements. So when you scroll it, you see, for example, teasers or videos or whatever. There's the hero page, which is kind of similar, but it has this parallax effect. We use it more for stuff that looks like an article, more to explain more about brands and stuff. We have the lookbook, which is inspired from kind of magazine articles that used to flip into 3 pages. So it kind of give a deeper visual impression. And we have the gallery, which you can swipe through. And even if you press on it, you can still swipe through into more details. So how does this all work? Like, how does these elements implement it? So this is basically the fun Swift part. Okay, enough of the marketing shit. Every element has a model, a builder class that can create this model from JSON, and a view controller and a storyboard. So you might think, for each element we have 4 files. Why? The thing is, each element here we created in vacuum. So the elements don't know anything about each other. They're not dependent on each other. Even the teaser element, for example, is not dependent on images or text, or the other way around. So each element doesn't know about its children, if it has any, and each child doesn't know that it can be contained in a parent also. So the idea is that all of them become very separated. So when, for example, we want to add another element in the future, we don't have to plug it in a million different places. We can just add it, and then it can work with all of them combined. The builder class is in charge of turning the JSON into the model. The model is quite clear, and the view controller is just there to manage the storyboard. Protocols. We've achieved being able to separate all the elements from each other, they can still work with each other, but without knowing about each other with protocols. And Swift protocols played a very big role in that. So you can think of the elements as the building blocks for a flexible layout kit, and the protocols is basically the glue that holds everything together. We have 6 main protocols that I would like to explain. The first 2 are the containable and container protocols, and these So for example, if an element is containable, this means it can be contained inside each other elements. So image element, text elements, all these conform to the containable protocol. And it's basically there so they can tell their parents about sizes. So they can say, they can specify their size they would need to lay out themselves. And also the teaser element, for example, although it's a container because it contains images and text, it also conforms to containable protocol because it can be contained in a list, etc. So most of the elements are containable and containers. The container protocol is there for so that the child can tell its parents basically to update the layout if something goes wrong, so just force an update of the layout. The actionable protocol we use so that elements can call actions. Usually it's deep links so that we can navigate to other parts of the app. The element model and the element controller was also implemented as protocols. This might sound weird because they could have really been subclasses. But the thing is, when we started, we didn't have this architecture set first. We weren't set on using a storyboard and a view controller for each element. First, when we started, it was UI table view cells prototypes and UI table views or collection views. And then we moved on. It didn't work quite well, so we moved on to UI views and nibs. Also didn't work out quite well, so we moved on to the view controller and storyboard for each element. But because the element model and controller were protocols from day one, we were able to move from one architecture to the next, one implementation to the next, and keep these on the side without having to change them every time. If they were subclasses, they would have first been subclasses of UI table view cells, for example, and then they would have been subclasses of UI views. So it had to change them a lot, but keeping them as protocols kind of abstracted the whole implementation quite well. Yeah. The last protocol is the element builder protocol. And this basically is called when, for example, we see an element type in the JSON that is text. So we know we need to wake up the text builder and tell it to validate this element and convert it into, or give us the text model. And so it has just validation from the JSON to make sure all the required attributes are there. And then it creates the model for us, and now we're ready to create the controller and display it on the screen. Yeah. The main integration point with the framework is called the FlexibleViewController. It's basically like a UI table view controller. You subclass it like you do with any view controller, and then you give it the JSON, and then it will start rendering everything on the screen. It will take care of everything except the networking, of course. You have to supply it with the JSON just ready. So now I would want to show you a quick demo of how this looks on the screen, and then I'll show you some code, show you some of the implementation, and then show you how we can add our own SwiftConf element to the flexible layout kit, because this is kind of the interesting part, because most of the work we've done was trying to keep everything abstract so that when we, in the next release, when we try to add a new element, it's not that big of an issue. So yeah, let's do that right now. Okay. Yeah. So this is an example of a JSON template. Of course, here it looks very bad, but if we build and run, we should be able to see it. Yep. Okay, so this was the home screen for the iOS app maybe 2 months ago or something. I pulled this old template when I was preparing the slides. So this is how it normally looks. So this is basically a list element that contains teasers, and usually when you press, they would take you to the catalog or different parts of the app. Yeah. but I have no networking here, so it has to. This is all cached. Yep. So let's go and add our own element ourselves. So here, this is I guess where the first element is over. Yeah, so this is where the first teaser basically ends. So I'll add our element here. So as you can see, it's an element type of SwiftConf, has an image, has a name, and then has a width and height. We usually use the width and height to maintain the aspect ratio of the images, so that usually use the full width of the iPhone to display images, but for different phones, there's different sizes, so that the width and height guide we calculate the aspect ratio from here and then scale the images accordingly. Yeah, so I add the element, I build and run. And of course I don't see it because we've just added JSON, we didn't add any code. So, but this is basically a good example of what will happen when we update the framework and release a new version of the app with more elements, and then we start using it in the CMS, but this template is sent to an older versions of the app. Our kit just, when it's validating the elements, it disregards any elements that it doesn't know anything about. It just skips it and continue on, so that even people with older versions of the app would still see most of the content except the new elements. That just doesn't happen a lot. Yeah, so like I said before, for each element to work, it needs 4 files. So I have them right here. Let's go through them. So the first basically is the element model. Basically, like I said, has a URL, a width, height, and a name, and these are takes full screen width. It's just a bool that specifies that yes, it works full screen, and the UID, just a unique ID that we use for caching, so that we don't have to. If we have seen this element before, we don't have to fetch it or anything again. And then there's the aspect ratio calculations, the sub-elements if it has any, and then the init method. So it's a very simple protocol struct. The builder class, what it does is that it knows what attributes are required. They have to be in the JSON, and this element won't show on the screen without. And then it just validates these attributes that are there with some guard statement, and then it creates the SwiftConf element. So it's just also very straightforward. For the SwiftConf element, this is how the storyboard looks like. Just a big image view with the name label on the top right. Just an example of how you normally set up the elements. It's really also cool that each element has its own storyboard, because it decouples everything and makes working with UI very easy, because you have a storyboard, yes, but it just does one simple thing. So it's you don't mess up with a lot of constraints or a lot of stuff, because it's very, your UI is partitioned, so you're just working on a tiny part of it. So you never have, ambiguous layouts or anything like that. The controller, here also for this element is quite simple because it doesn't do much. The work in the controller varies based on elements, but now it just have a configure controller function that sets the image and sets the name. It has a content size function which comes from the containable protocol. This tells the parent the size it needs, and then a prepare for use that works just like how UI table view cells clean themselves up for reuse, because we also reuse the controllers for performance issues. Yeah, so we've added the element in JSON. We've added the 4 files. We just have to do a couple more things just to tell the layout kit that this element actually exists now. So to do this, we have to just added some mappings. Yeah. So. Sorry. So we have a controller registry that basically maps the identifier of the element to the controller, so that we know when we get this model, we have to instantiate this controller that knows how to deal with it. So I've added now the SwiftConf element mapping to the controller. We have also we also have a mapping from the element type ID to the builder, so that we know which builder, when we see it in JSON, we know which builder to instantiate that can actually create the model. Yep. And then we have an ID for each element that we look for in JSON to know that when we see SwiftConf element, we have just an enum that keeps track of all the IDs. Now when we build and run, we should be able to see our element. Come on, Xcode. Okay. Yep, here it is. Now we see the SwiftConf element inside the so it was a lot of work to add our own element. It was just basically we have to implement this element, and then hooking it up to the flexible layout kit was just not so much work. And we didn't have to touch any of the implementation of the framework itself. We just have to conform to protocols, and then we're good to go. We've been using a flexible layout kit in production ever since last December. The plan is to eventually open source this, because a lot of content apps have the same issue. They want to be more flexible. So eventually we should open source it. It's just taking us longer than we thought it would be. Yeah, and that's it. I'm happy to answer any of your questions.
So, yeah, questions?
Do you intend to open source as well the web CMS? The CMS part?
So, yeah, so basically the web CMS is why we haven't open sourced yet, because kind of till now we're doing it manually, or we have a CMS, but it's not so easy that anyone can basically do it. It requires a lot of manual editing and stuff like that. Okay. So the plan was to either create a CMS, a very nice one that makes it very easy to edit, or create a Mac app that does the same. But yeah, we're just waiting for this to happen, and then we can open source it as a package that does it.
All right, give it back.
So you're using storyboards for the visuals for each element. Why not zips? Do you have transitions there too, or do one element link to another one with segues?
No, the elements don't really link to one another. The elements, if the elements want to create take you somewhere else or push you to other parts, they can call an action, and we usually use deep links for that, so that elements can take you otherwhere in the app. We were using nibs first and UI views, but we wanted to switch to UI view controllers. And it was easier to just use storyboards with UI view controllers than zip files with UI view controllers. So it was just an implementation, which just made more sense when we were writing it. But the problem with storyboards and UI view controllers is that they have way too much overhead, especially for smaller elements. So for a list or something, the overhead, makes sense because it helps with scrolling and all that. But for a text element, when it's a view controller, you know, it still calls, you know, all these like view did load, view did appear, and all it does at the end is create a text field, a UI label. It's too much overhead, but we found out that it's easier implementation wise to do it that way, and then we can work on the smaller parts to do like a faster way for the small elements like text or just image or something like that. Yeah.
All right.
Hey, thanks for the talk.
Yeah,
I think I missed it. Do you use auto layout in the storyboards?
yeah, we do.
And have you considered to use to do that in code instead of storyboards? Because if the elements or the what you put in there are so few, I think it could be also done in code and maybe even faster or easier to maintain.
Yeah, it can. We have this argument about whether to do auto layout constraints in code or on storyboards like every day. My team is kind of split. Some people like to use storyboards all the way and others don't. From my experience, it's easier to change stuff later if it was a storyboard because it's more visual, so you open a storyboard, you understand what's happening, and yeah, I want to change this constraint to that. But if it's still easy to write the constraints in code, but when someone else, you know, comes 6 months later and they want to change, it takes them, you know, like 15 minutes to try and understand what these constraints does and then start changing them. So we decided, like, the storyboard half of the team kind of won here, and we've overpowered the rest. Yeah.
Okay, thanks.
So I had to leave the room for like a minute, but I don't know if you mentioned, I read a couple of days ago somebody wrote like a converter from UIKit to storyboard file, something like that, something that generates a storyboard. I didn't really check this, but yeah, because the number one problem obviously with storyboards is if you work in a team.
Yeah.
All right, somebody else has a question? Nope. All right, then big round of applause again.
Thank you.
Awesome talk. And so now let's make a quick break again, like worst case 10 minutes, and then we'll come back and have Greg's talk, and after that we will have lunch. So go outside, get some fresh air, and refill, and see you in like 9 minutes.